Welcome to today's Explainer. Okay, so we are unpacking a massive, I mean literally industry-shaking paradigm shift in the world of software engineering today. Agent-first development. For decades, right, the core identity of a software engineer was, well, someone who wrote code. But suddenly, we're rapidly transitioning from being code producers to task orchestrators. It's this fundamental, ground-up shift from being a maker to being a manager, and honestly, it is happening way faster than anyone predicted.
Okay, let's dive into this agenda. First up, we'll look at the agent-first paradigm. Then we'll go inside Google Antigravity and map out an autonomous bug fix pipeline. After that, we'll uncover some hidden AI blind spots, do a quick developer reality check, and finish up by looking at the future of coding.
All right, Section 1, the agent-first paradigm.
To truly understand where we're going, we've got to look at this stark contrast. Over on the left, you've got traditional IDEs. That meant typing line by line, where the system kind of only really understands the specific file you have open at that moment. But on the right, with agent-first IDEs, we're moving to fully autonomous tasking. These agents have repository-wide understanding. You aren't just writing a function anymore, You're assigning a massive, complex goal to an automated agentic loop that just navigates your entire codebase on its own. This is that whole manager versus maker dynamic officially taking over.
Moving on to Section 2, inside Google Antigravity. So, Google's Antigravity IDE is absolutely at the forefront of this, powered by the immense speed of Gemini 3.5 Flash and these asynchronous subagents. What this means is, while you work, multiple agents are running tasks in the background, without freezing your screen, which is huge. The agentic loop itself operates in 4 core phases. First is planning, where the agent maps out its approach, often spitting out visual markdown artifacts. Second is execution, where it actually modifies the code. Third, and guys, this is the real game changer, is verification. The agent runs its own tests. It actually proves the code works before moving to the 4th step, documentation. It doesn't just guess, it verifies. Absolutely crucial.
So the crucial point here is that with all this automation, there's a built-in safeguard. Human in the loop, or HITL. Antigravity actually introduces this brand new manager view dashboard specifically so you can monitor all these concurrent agents. You get progress bars, you get artifact previews. Because despite all this incredible AI autonomy, the human operator, that's you, retains the ultimate steering wheel. You hold the final approval.
Next up, Section 3, the autonomous bug fix pipeline.
Okay, here is a brilliant real-world implementation using Firebase and Claude. I want you to think of this pipeline as a relay race. Step 1, a user submits feedback in a mobile app which hits Firestore. Instantly, Step 2 kicks in. An AI classifier, specifically Claude here, analyzes the text, determines if it's a technical bug, and assesses the severity. If it's a bug, Step 3, the system actually clones the repository into a temporary folder to fetch context. Step 4, the agent runs its tools and tests. And finally, Step 5, it opens a fully verified pull request on GitHub. So, from a user complaining about a crash to a tested PR waiting for your approval, this entire relay race takes literally just 90 to 180 seconds. It's breathtaking, honestly.
But wait, how does Claude actually execute Step 4 without, accidentally deleting your entire production database? Well, it all comes down to these highly constrained core tools. The AI is given a very strict set of JSON-defined abilities. It can read files to understand the codebase. It uses code search to grep for keywords. It uses a write fix tool to patch the exact file. But crucially, it must use the run tests tool, like literally running your Jest or Flutter tests right there in a sandbox, to ensure the fix actually works. Only if those tests pass is it allowed to use the open pull request tool. These constraints are exactly what keep the AI both safe and productive.
All right, let's get into Section 4, fixing the AI's blind spots.
Now, what's really interesting about this slide is that it shows it's not all smooth sailing. Actually, scratch that, it can be a real headache. When seasoned implementers tested these prompts against advanced models like Gemini, they found critical gotchas that would literally crash the whole system. First, the Git off catch-22. Standard Git clients can't just magically use a raw GitHub app token. They actually need a highly specific, structured HTTPS token URL injected right into the command. Second, sandbox test isolation. Look, if the agent tries to run npm install inside a Cloud function to run tests, it's going to time out for sure. You have to use pre-installed, globally cached binaries. And third, file system cleanup. If you don't recursively wipe that temporary clone folder after every single run, your Cloud container will just run out of memory and crash. These are those subtle edge cases that separate a cool weekend demo from a true production-ready agent.
Which brings us to Section 5, the Developer Reality Check.
We are facing a really fascinating set of trade-offs right now. On one side, anti-gravity offers just blazing speed and high autonomy. But, it's prone to looping, that frustrating thing where the AI gets stuck trying the exact same failed fix over and over, and of course, unexpected crashing. Compare that to the traditional VS Code experience. It offers consistent speed and rock-solid stability. When things get complex, the reliable manual debugging of a traditional IDE still kind of feels like a safety net compared to an AI that might just be chasing its own tail.
There's a quote here from an engineer experiencing this shift firsthand, and it is incredibly profound. They said, "At first it feels like magic, but eventually you realize that constantly playing the manager role can be more exhausting than just writing the code yourself." It perfectly hits the nail on the head regarding this massive psychological shift. Developers are actually mourning the loss of their traditional coding flow state.
And that quote leads perfectly into this concept right here, decision fatigue. When you're the maker, you get into a zone, right? A rhythm. But when you become the manager of an AI, your entire job suddenly becomes evaluating, verifying, and approving this just endless stream of micro-decisions made by the machine. I mean, if you've ever felt exhausted reviewing a junior developer's pull request, just imagine doing that 100 times a day with an AI. It's a surprisingly heavy psychological burden for the industry to adapt to.
Finally, let's look at Section 6, the future of coding.
So where exactly is all this technology driving us? Well, and this brilliantly illustrates it, we are looking at a horizon defined by multi-agent orchestration. Just imagine a front-end agent, a back-end agent, and a DevOps agent all talking to each other to launch a feature. We're moving towards self-healing repositories that detect their own bugs, write the fix, test it, and deploy the whole shebang while you're literally asleep. Ultimately, the goal here is real-time human-agent collaboration, working shoulder to shoulder with AI in a shared workspace.
The technology is undeniably here, and it's incredibly powerful. But the real question we have to ask ourselves is, are we ready to trade our traditional, focused flow state for a fast-paced, high-stakes managerial role? As we transition from coders to orchestrators, how we adapt to this new psychological landscape is going to define the next era of software engineering. It's definitely something to think about the next time you sit down to write, or rather, to manage your code. Thanks so much for joining me on this explainer. Keep learning, and I'll catch you next time.